In lesson 21, we're going to be adding like terms. We actually covered this the first time we went through like terms. I think we wrote out these two steps. Step number 1, check to see if all the variables are exactly the same. If they are, it doesn't mean you have like terms, but you're halfway there. If they're not, you can stop. You can't add them because they're not like terms. If all the variables are the same, you go to step 2. And then you ask, are all exponents on all variables the same? If they are, you can add them. They're like terms, or subtract them. If they're not, you can't add them. So when we look at this here, we have 1 term, 2 terms, 3 terms, 4 terms. And the directions when we're dealing with adding like terms are going to be simplify. So again, we're going to look for apples and apples and oranges and combine what we can. The 2 would be considered a coefficient, positive 2, xy squared is p to the 5th. Here's a positive 3, p to the 5th, x squared y. Negative 7, and we don't have anything listed here, so we consider it a coefficient of 1. So let's see if any of these are like terms. We start with step 1. Let's just look at this guy here and see if there are any like terms with him. So we start with, are all the variables the same? Well, let's check the variables here. Coefficient doesn't matter as far as whether something is a like term or not. We've got an x, y, and a p, and we've got an x, y, and p. So it passes step 1, so we'd go to step 2. Are all exponents on all the variables the same? Here you have x squared, here you have x to the 1st, so it does not pass that test. Doesn't matter if y and p would have matched up. For example, both p's are p to the 5th. But it says all exponents on all variables the same. So these first 2 terms are not like terms. Let's see if the 3rd term matches up with the 1st term. Here we've got p to the 5th, p to the 5th, x squared, y, and y. So this 3rd term is a like term with this 1st term. Let's see if the 4th term is also a like term with terms 1 and 3. We've got y squared, and here's y and y. So the 4th term is not a like term with the 1st and 3rd. So we have 1 x squared y p to the 5th, and we have 3 more x squared y p to the 5ths for a total of 4 x squared y p to the 5ths. Let's see if terms 2 and 4 match up. We'll say we covered these already. We've got x, y, p, p. So it passes step 1. We go to step 2. Are all exponents on all variables the same? X to the 1st, y squared, p to the 5th, p to the 5th. So this is like these are oranges. If x squared, y, p to the 5ths were apples, these are oranges. So we've got a positive 2 and a negative 7 for a total of negative 5. X, y squared, p to the 5th. So what we did is we simplified these, or this expression, by adding the like terms. Sorry about that. Alright, another example. Just tried to make this one with a bunch of terms, and I don't think it's going to confuse you, but here's a term. Here's another term. Not doing a very good job circling here. A bunch of terms in this expression. In fact, 1, 2, 3, 4, 5, 6, 7 terms. Directions are going to be simplify. I'm going to rewrite these terms so they look similar. This is a squared b minus 3aba can be simplified to a squared b. Almost forgot the 3. Plus 4ba minus 2ab b squared plus 4a squared b squared minus 2ab plus 3. Here's another one we can simplify, a squared b squared. So I simplify those guys. Now I'm going to circle them again so I know which or where are the divisions of my terms. And then we're going to start our test. First we look for variables that are the same. Well, all of these guys have a's and b's, so they're all going to pass the first test. AB, 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 and AB. But not all the exponents are the same in all the variables. Here we've got a squared b. Do we have any other a squared b's? Here's an a squared b. Here's a ba, a b squared b squared, ab, a squared b squared. So these are the only two a squared b's. So we have a 1 a squared b and a negative 3 for a total of negative 2 a squared b. Here we've got a BA, 4 BAs. Any other BAs? Just b to the first, a to the first. Well, this one's b squared. That don't work. A squared b squared. Here's one. And the last term is a squared b squared. So we have positive 4ab and negative 2ab for a total of positive 2ab. We've got ab squared. Doesn't match up with this one. This is a squared b squared, and this is also a squared b squared. So this guy is on his own. And then finally these two are like terms. A squared b squared, a squared b squared. The exponents on the variables are exactly the same. So a positive 4 and a positive 3 gives us positive 7 a squared b squared. So even though these guys kind of look a lot alike with being a's and b's and having some squared, all of these are different terms. So there's nothing more we can do other than leave this as our most simplified answer.